Before I get going, I do want to thank quite a large group of different partners that we have in the area here that have worked with us either directly on the project or consulted with us or provided advice on the project over the last several years. And then we really do want to thank Representative Thad Altman and Representative Randy Fine and Senator Debbie Mayfield for their support for this project and for the lagoon in general. I'm not going to belabor the points about the status of the lagoon and the health of the lagoon. You all, I think, are very familiar with that. But I will emphasize that we are approaching this from a perspective of exploring whether enhanced ocean circulation can improve water quality and then all of the related benefits that would come from that. And we recognize that the lagoon is in really tough shape and that we need to explore all the tools that we have potentially access to. The issues with lagoon health have been long coming, and they've been recognized by many folks, including you all on the committee, for quite a while, and people have been working hard to address these concerns with some significant successes. Inflow and enhanced inflow has been an idea that's been kicked around for quite a while. Often we hear it as, let's just cut a new pass, a new inlet, and improve circulation that way. That's a challenge. There's many challenges with that, including just the permitting from U.S. Army Corps of Engineers. But we want to explore whether maybe some other sorts of system, maybe an active pumping system or a passive system, might actually be able to effectively improve water quality in the lagoon. This is an idea, as I mentioned, has been around for a while, to the point where the IRL-NEP in their CCMP identified specifically doing a pilot project to look at the impacts of inflow to see if it's really going to be worth the challenge of a larger system and moving enough water where you would have a meaningful impact on water quality. So this is directly recommended by the CCMP. And the idea is you need to move the water, you need to actually exchange water and see if some of our predictions, whether they're predictions in favor of improved water quality or they're potential negative impacts, predictions about negative impacts that we might have, whether those really come to be the case when we move water. And then with that data in hand, we can make a meaningful decision about whether this is something to further explore as an option for improving lagoon water quality. The project builds off of work that's been done elsewhere, successful inflow projects in Destin, which has a pump that's been operating for 30 years to address hypoxia and fish kills that were occurring in Destin Harbor. Obviously, that's a much smaller system than the Indian River Lagoon, but they've been able to run that pump effectively for 30 years at a relatively minimal cost. And other projects elsewhere that actually do use a similar strategy, just enhancing circulation, whether through a breach in a beach or through artificial pumping in Los Angeles and then across the globe. So these are ideas, and not just ideas, actual interventions that have been established, in some cases for decades. And over and over and over again, what they see in each of these cases is that there are direct improvements to water quality. Each case, there's a unique response to each system and to the intervention strategy. But over and over again, they do see that there are improvements to water quality. This work here is also building off of a feasibility study that was conducted by St. John's, and they were contracting through CDM Smith, initiated in 2017. That work, I think I saw that was mentioned in your project plan. There was some discussion about the successes of that work and their recommendations. We've been building off of their work. They had indicated as well as the CCMP had indicated was that a pilot project would be needed. They had actually recommended a pumping of 5 cubic meters per second from Port Canaveral specifically, or passive exchange of similar volumes of water, in order to be able to test the ideas and the predictions that we have about pumping impacts. We see enhanced inflow as a tool that may help improve water quality as a complement to existing tools. It is not a silver bullet by any means, no matter what folks might think about, cutting an inlet or installing an artificial inflow system. It is not going alone. It's not alone going to solve the problems of the lagoon. The nutrients removal is a big part of these challenges that are going to be faced. There's many projects that you all are very closely involved in and have implemented in the county here, that inflow may potentially help benefit. So in synergy, the multiple projects may be able to restore the system to a point where we actually we're able to restore seagrasses, we're able to restore filter feeders, and then we have compounding benefits from there. So a quick big picture of how the project's structured. We have a principal question that everything ties back to, and it's whether can enhanced inflow actually help stabilize and restore the lagoon. I mean, it's a very general question. We have many more specific questions that we're asking to be able to come to the determination of whether inflow is going to be a benefit to the lagoon or not. But we're exploring this question from a variety of angles. We're examining the hydrology through modeling efforts that are being led by Dr. Zarillo. We're looking at the geochemistry, which is the work is being led by Dr. Austin Fox. And we're also recognizing that there are potential benefits that would come from enhanced inflow to the communities, to the fishes, to the habitat builders. But there's also potential negative impacts that we have to keep in mind. We have to actually directly evaluate, because a large engineering intervention that's being considered, dumping large volumes of water from the ocean into the lagoon, before we initiate a project of that sort, we have to be able to better predict how the system is going to respond, both positively and negatively. And so we have a variety of independent or related studies that are addressing each of these components. And then we also have a team that's looking into just the technical considerations of the engineering of a pilot system, which is what we're proposing, but then also exploring alternative designs for a full system if it looks like from the data that's something that we will either recommend or is going to be potentially worthwhile. In the end, what we're proposing, based on the historical data we've looked at, based on prior studies that have been conducted, based on new data we've collected and new modeling that we've done, we're proposing that we need a pilot study in order to be able to test some of the predictions that we've established. And this pilot study that we're proposing is relatively small scale. We've made some changes to the proposal that was generated by CDM Smith in their studies that was commissioned by St. John's River Water Management District. We've scaled back the pumping volumes. We made some changes to the configuration that will allow us to establish a pilot project with relatively low cost and relatively little potential negative impacts, but still providing a meaningful testing of some of our predictions, or of most of our predictions. So again, still trying to stay up kind of big picture here in 15 minutes. I do want to share with you some of the specific questions that we are looking at. In order for pumping to actually be a benefit to the lagoon, we need to, it has to have a meaningful impact on nitrogen loads and phosphorus loads as well. And then from that, we need to see a meaningful impact on chlorophyll A abundance. If we're not seeing those changes, then we would not recommend an inflow system. With those changes, we also would expect to see, and we're predicting to see, improved bottom water dissolved oxygen concentration. And then a whole related improvements to water quality tied to the potential for improved dissolved oxygen. But then again, we need to recognize that while we have many potential benefits that could stem from a project like this, there are also the negative aspects that we need to consider, negative impacts. A few of them that we're specifically looking into are listed here. So this is a multi-phase project. We have already completed phase 1 and phase 2. This was state funded, and the monies, the funding is being run through the Florida Department of Education, which restricts us to annual cycles for our funding. And so that's, you can see the phases are aligning with the budget years that we were funded by the states. And so each year we've been building off of the prior year results. In year 1, we were building off of prior studies and looking at more detail at some of the sites that were recommended for a potential inflow system, getting in the water and actually exploring those sites to better understand whether it's really an appropriate location for an inflow system relative to other locations. And as well exploring the feasibility of an inflow system at that location. In phase 2, we've expanded on that with the determination that a pilot system is needed, and with the realization that we can scale back the pilot system in a way that allows us to conduct this research without having to manage the costs and the permitting considerations of a 5 cubic meter per second system or bigger, which is what has been previously proposed for testing of inflow. Phase 3 is pending right now. We are proposing construction of this pilot system. And I'm going to go more into specifically what we're talking about for the pilot system in a second here. The construction of the pilot system will allow direct and indirect testing of predictions that we have developed over the last several years based on prior work and based on the work we've been doing, the modeling and the direct in the fields data collection. So we have a number of findings or just results from our past 2 years worth of efforts that we're building off of here. One of the things that we recognized right away when we were looking at the CDM Smith study and in our conversations with U.S. Army Corps of Engineers was that a system at 5 cubic meters per second was going to have a potential significant impact on a large portion of the Banana River and obviously have quite a significant cost as well. We then decided to see if we could modify that approach to provide for a relatively cost-effective and low-impact research design that allowed us to, again, test these predictions that have been developed by each of the different teams for their related areas of focus. Right now, we are proposing a temporary pilot project. So an operation of a year is what's planned right now of a small-scale pump moving 0.5 cubic meters per second from Port Canaveral into a cove that's just south of the Canaveral locks. And so I don't know how well you can see this here, but there's a cove down here just south of the locks that we recognized would help constrain the flow a bit if we were to be moving port water into this cove. Whereas outside that cove, if you move to other locations, if you move water into other locations, the water would quickly, the inflowed water would quickly diffuse into the Banana River in this case. And what happens is that you have to pump very large volumes of water to establish the changes in the water quality, the water chemistry that you need in order to be able to test your predictions. If we confine the flow with this cove, and initially we were actually considering figuring out how to confine the flow with something like sediment curtains or something of that sort. But then we realized we would be better off if we took advantage of some natural geography in the area and we realized that there was a perfect location just south of Canaveral Locks where we could confine the flow and then at a small volume alter the conditions in this cove to a more marine-like, less eutrophic system, and then gives us the opportunity to test some of these predictions that we've developed. You can see over here on the left just the general schematic for the pilot pumping system that has been reviewed by our U.S. Army Corps of Engineers. They've been approving, they've offered feedback on this design as we've been discussing with them over the last year. Our last meeting with them, there was the 21 members from the U.S. Army Corps of Engineers on the call providing direct feedback about this pilot design in particular, and the possibility of using their land to be able to run the pilots. And so we've also, as part of this, we've been in conversations with Port Canaveral for the last year. Both groups right now are in support of the pilot projects. Nobody is saying anything about a full-scale system. They're in support of a small-scale pilot project to be able to generate the data that then stakeholders and managers can use to determine whether a full-scale system is worth considering. And the location of full-scale system, the nature of a full-scale system, that is not up for determination right now. What we're doing is we're talking about a small-scale pilot project, move water into the Banana River, and test our predictions that we have. As part of being able to test predictions about the impacts of inflow, we've been assessing the biological communities. We're expecting and predicting positive benefits to a number of the biological communities within the lagoon with inflow. The modeling work that's been done by the fish team, building off of 30 years of data or leveraging 30 years of data from the FWC Fisheries Independent Monitoring Group here led by Rich Paperno and Doug Adams. That is allowing, from that, the team developed a model to be able to better predict how fishes, the community as a whole, and individual species would respond to inflow. From that, they've seen that there are a number of species that would potentially benefit from inflow, while there are others that may actually be negatively impacted with inflow. These are predictions that need to be tested through an experimental system. We have as well been monitoring plankton dynamics in order to be able to directly track how that community responds to changes in the water quality with inflow. We are predicting benefits to seagrass coverage and are directly monitoring seagrasses in the vicinity of the experimental site that we've developed. I forgot to mention earlier, but as part of the pilot design, we've identified not just the cove as kind of our experimental site where we're proposing to move water, but we've also identified sites outside of there, and particularly one region to the south that is going to be our reference area, where under low volumes that we're proposing for the pilots, we will not impact the reference site. We'll preserve the reference sites for comparison to the experimental sites to allow us to directly disentangle just natural changes that occur in a highly dynamic lagoon, seasonal and annual changes, from the actual impact of inflow. We have, as part of biodiversity monitoring, we're also doing complementary assessments of environmental eDNA, complementary detection of environmental eDNA, which basically is allowing us to track or assess fish communities without actually putting a net in the water. And the results of that work and the results of all of this work are available in our year 1 and year 2 reports. We've been working, because of a concern about marine mammals, we've been working with NASA to better understand the current status of marine mammals in the Banana River Lagoon, and then how we might actually better assess the impacts of inflow on those marine mammals. We can confidently predict that if we were able to recover seagrasses through inflow, there'd be benefits to marine mammals. But there are some negative impacts that have to be considered as well, including the potential for drawing in marine mammals to that area where the inflow is, and then creating the potential for additional negative interactions between manatees and boats, for example. And we'll be working with NASA as we move forward. At least that's the proposal right now, to be able to look at that specifically. So a question is, or one of the key findings that we've had is that this is based on primarily data from this last year, but from year 1 and year 2 combined, is that inflow can actually improve natural nutrient removal. This is building directly off of the same processes that Austin is looking to promote through improved aeration and or capping of the muck with new sediments and raising the water level and reducing the chances of hypoxia in those sediments. And so we know that, as Austin mentioned in his prior talks, when the dissolved oxygen concentrations get low, sediments are releasing their nutrients. The nutrient ratios that are then promoted in that situation actually promote the growth of HAB species, and in turn end up impacting seagrasses. Right now, based on primarily on the work that Austin has been doing in the lab and in the field, he has shown that inflow will stabilize, if inflow does as predicted, stabilize DO and lower water temperatures, we're going to see increased nutrient uptake by the sediments. We're going to see improved nutrient ratios. That together is projected to estimate for just the pilot pumping rates a value of $9 million in nutrient removal. This is based on the estimates for the cost per pound of removing nitrogen and phosphorus that have been worked up for Brevard County to better evaluate these different inflow projects. So based on that average cost per pound, the nutrients that are predicted to be removed from just the pilot project alone have an estimated value of $9 million per year. And why am I not forwarding now? That's interesting. We also predict that there will be a net nutrient reduction with inflow. So net meaning across the IRL region. The modeling efforts indicate that the particular direct benefits of inflow are going to be confined to the Northern Lagoon because of the nature of circulation there, including seasonal changes in circulation patterns due to changes in the lagoon level that actually relate to changes in the Gulf Stream velocity. Really fascinating interaction between offshore Gulf Stream processes and the lagoon level, and then potential nutrient loading, seasonal nutrient loading in the northern BRL in particular, that Dr. Gary Rizzarillo has identified. When he integrates that data into his models and looks at the impact of inflow, we do see that there is a confinement of the potential impacts, the direct impacts to the northern compartments of the IRL. But that means that also potential direct negative impacts are confined to that area as well, which is a concern for folks, in other areas. With inflow, we're going to have higher water exchange. More water comes into the lagoon, that means more water moves out. With that, you are increasing the nutrient loading offshore as you move more water offshore without changing the nutrient concentration in any way whatsoever in a given parcel of water. But right now, what we're predicting based on the modeling efforts and some of the work that Dr. Fox has done is that increase is less than 1% and significantly less than 1% in most cases. We see from the modeling efforts that there's no detectable change in inlet nutrient concentration with inflow. And that's an important point to identify. And then we see, which is even more importantly, that across the lagoon, when we take into account the predicted changes to nutrient cycling within the Banana River Lagoon, and then the nature of the circulation patterns, what we see is a net reduction in nutrient loads with improvements to dissolved oxygen in lower water temperature that are predicted with inflow. So basically what we see is improved the improved DO, the lower water temperature, promote nutrient cycling that actually draws the nutrients out of the water and ends up with a net reduction in nutrient loads across the region. And then with that, I want to emphasize that all of our reports are publicly available. Our most recent reports, a 500-page reports for finalizing our year 2, summarizing our year 2 data, will be available online. We have recognized, we definitely appreciate that most folks aren't going to want to dig into a 500-page technical report. So with Tetra Tech's help, we've actually refined that down to a 100-page, still fairly detailed summary of our year 2 work. That's going to be available online, and we have an executive summary of 4 pages as well that will be available, and we're happy to share with anybody. And at any point, you're welcome to reach out with particular questions. If we can't address any